Alright, let's try this last one. So we want to find the transformation that moves z to iz. So we're going to say that z is x plus iy. And so that would mean iz is equal to x plus iy times I. So we distribute that and we get ix plus I squared y. I squared is really -1. So we end up with this, which if we order that correctly, we end up with that. So here's our z, here's our iz. Okay, now we know that z can be represented as pxy, and so iz can be represented as p prime negative yx. And if we find the length of each of these, this one's pretty straightforward. It's just x squared plus y squared under a square root. And then if we do iz, we're going to get negative y squared plus x squared. Negative y squared is just y squared. And then that's the same thing as x squared plus y squared under square root. So they're the same distance. If we plot those on a graph, we're going to be we're going to get xy. So we might do like 1, 2, 3. I don't know. If we just like chose a value. So if we're thinking of this like 3, 4 maybe. 1, 2, 3, 1, 2, 3, 4. It would be there. That would be p, and this would be xy. And then if we used those same values over here, it would be -4, 3. So we'd say 1, 2, 3, 4, 3, something like that. Now, if we were going to do that, we could find this angle right here. We know this is 3, this is 4. We know that this is 3, this is 4, and that's going to maintain that this is 5 in this case. We don't need to know that though, but we're going to have a tangent of, like if we call this one our theta, tangent theta is equal to 3/4, and over here tangent theta is going to be equal to 4/3. Okay, so if we do this, we'll find the inverse tangent. So we're going to do mode degrees (3/4). Okay, so that gives us 36.9. for theta. And then if we do same thing but 4/3, we get 53.1. Okay, now we know the total of this is 180. So if we do 180 minus both of those, it will leave us with our answer. And that's 90 degrees. So what that means is the transformation is a rotation counterclockwise by 90 degrees, or we can change that to radians and get pi halves. If you have additional questions, please come to Math Lab. Until then, calculator.